is going to be easy. Okay, here's the notes for ellipses. We're doing the units on ellipses. And this is worksheet 4. Worksheet 4 ellipses. Okay. All right, so we're familiar with the format, the standard equation of an ellipse, right? It should be something like this. An example. This is just an example. We're not going to graph it. I'm just showing you that we know that it should be something like x plus 5 squared over like 36 plus y, it could be plus plus, it could be minus minus, whatever. But the point is, we know that this is squared with a number down here. We know this is squared with a number down here. Like up another perfect square number, hopefully. And then remember, they have to be equal to 1. Yeah? This is the most important part right here. They got to be equal to 1. Yeah? That's the part we're going to focus on today. You're going to have equations that don't have a 1 here. That do not have a 1 here. Okay, so here we go. But you know what? You know how they're supposed to look. Okay, so here's number 1. So pretty much, I think it's going to say like write each equation, obviously for an ellipse, but I'm not going to write all that. Write each equation. All right, for an ellipse. And I think they call it in standard form or something. I'll check. Let me see over here real quick. That's okay. I'll check later. Okay, number 1. Let's just jump in. What about if it says this? 9x squared plus y squared equals 36. That's an ellipse. That's an equation of an ellipse. But you don't recognize it because it doesn't look like this. See? But the main thing you're just going to concern yourself with is this. Make this a 1. This over here has to be equal to 1, right? Not 36, not any other number. A 1. Yeah, everybody get it? Okay. So what would you do to this equation so that this is a 1? This number over here is a 1. Anybody? How do I make this a 1 over here?
Divide both sides by 36.
Divide everything by 36. Every term, right? Whatever you do to one term or anything on one side, you do it to everything or to both sides. Correct. That's still true. So if I divide this by 36, right? 36 divided by 36 is going to be 1. If I do it to this, you do it to everyone individually. So guess what? Divide each of them by 36. And what's left? What's left? 9x squared over 36, that's still left, plus y squared over 36 is equal to 1. Okay, I got it equal to 1. But now what? We're really supposed to have the x squared and the y squared alone up here, where there's not supposed to be any numbers. Right here, it's just like the x squared or the y squared part. So I'm okay with this one. I'm not okay with this one. Guess what's going to have to happen here? Anybody see it? What's going to have to happen here, you guys? These can what? Reduce or simplify. Doesn't 9 go into 36? Yeah. So what's really going to be left over? X squared over what? X squared over 4, right? 9 goes into 9 once, 9 goes into 36 4 times. And see, now this is the equation of an ellipse. Yeah? And then that's all you got to do. You don't have to graph it. Everybody remember what it means when there's no numbers up here? The center is what? Yeah, the center is 0, 0. So then you know how much you'd have to move from the x, right? 2 left, 2 right, and then up 6, down 6. But see, you're not graphing it. We're just getting it to this form. Everybody see what we're doing? That's it. Okay, let's do another one. Number 2. How about what about let me see. What if I put 16x plus 2 squared plus 4y minus 3 squared equals equals 64. That's an equation of an ellipse. Well, pretty much. What are we just going to make sure that happens here? This over here number has to be that has to be a 1. So what are we going to do? We got to divide everything by 64. Now I'm going to give you a big hint. This is what's going to help you out. It's not going to be true all the time, but most of the time it is. The two numbers that are here multiply to this number. Go ahead and try that. Check what 16 times 4 is. Let's see. What is 16 times 4? Just to give you a hint about this, how to reduce these. 64, right? So if it's true that 16 times 4 is equal to 64, if I know that, if that's true that 16 times 4 is 64, then you'll know how these reduce. If this is a 16 and this is a 64, right, because they're going to reduce, what's left over in the bottom? That would be what? X plus 2 squared over what? 4. Yeah? And plus what? And then how do these reduce? 4 times what is 6? Well, we already know it's y minus 3 squared is what? What's left over here? 16. You guys see that? Okay. Equals what? 1, right? That's the main thing. It has to be equal to 1. And isn't this the equation of an ellipse in standard form or in the completed square form? Yes, that's what we want. From here we can read the center, we can graph it, we can find the vertices, we can do all that. What's the center here? Just to, you know. What's the center on this one? -2, opposite of +2, opposite of -3. Okay, and so on. Okay, one more easy one like this, and then I'll throw a different one. Number 3. Oh shoot, what was it? Oh. Let's see. No, I used that one already. 9 times x minus 4 squared plus 25 times x minus 1 squared equals. Anybody have a wild guess what it's going to equal? Let's see if you're paying attention. Anybody know what it's going to equal? 225. What did I tell you that might be true in a lot of the cases when you see these? When you multiply this number times this number, it'll be this number. Right? Think of 25 times. 25, think of quarters, right? How many quarters does it take to you to get to $2.25? 9, right? Because 4 of them is $1, 100. Another 4 is another 100. That's $2. 4 and 4, that's 8. And then one more, 9, 225. Anyways, we know what to do, right? Just telling you what, just making this a little bit easier for you, these little hints that are going to help you out. Well, we're going to divide everything by and knowing this, right? Knowing this hint that what was the hint again? Oh, what happened to my green marker? No. It's out. What's the hint? That 9 times 25 or 25 times 9 is 225. That's going to tell you how to reduce, right? So 9 into 25, what's left? Huh? 25, right? That's going to be x minus 4 squared over 25 plus, and then that's how these reduce. 9 goes into 9 once, 9 goes into 25 times, right? 9 goes into 9 once, 9 goes into 25 times, right? Because I know this, because of this hint. Well, same thing here. 25 times what is 225? Yeah, see? Then 25 goes into 25 once and into this 9 times, see? Just telling you the hints to make this easier for you. E equals what? Equals 1. Okay, let me find one that is a little bit different. Okay, I see it. Let me go back to this. Okay, last one. Let's see what you do with this. Negative 64 plus y plus 9 squared. Oh, that's nice. Negative 64 plus 9 squared is equal to... oh, no, not that. That's fine. Is equal to 16x plus 2 squared. Actually, negative 16x plus 2 squared. Anybody see how they're trying to trick you here? Anybody see anything? I mean, this looks like, what the heck is this? This looks like nothing we've seen before. Anybody can tell me what's wrong with this? Well, let's see. Going back to our standard form, don't we want the parts that are squared on one side over here, and then whatever else the number on this side? Yeah, see, they just mixed it all up for you. Do I want one of them over here and then one of the squares over here, or should they be on the same side? On the same side. And then do I want no, I don't want this over here. So what should I move? Yeah, we're going to move this one to that side. It'll make it positive. And then we're going to move the number to the other side of the equation, right? Correct. So now if I move this over here, if I move the negative 16 to this side, that'll be positive 16, right? Because remember, when you move something to one side, from one side to the other side, it changes sign. Plus, and then this one's still here. And then now this negative 64, I'm going to move to that side. It's going to be what? Positive 64? Yeah. Okay, now everything looks like where it's supposed to be. Yeah, you want these to be positive. Your squares have to be positive. Okay, and then what? Divide everything by what? Well, this has to be a 1. So whatever this number is over here divided by what? Everything, all of them. All of them have to be divided by 64. All right, after you do that and you reduce, you will get your final equation in the standard form. Right, we got it equal to 1. That's the main thing. It has to be equal to 1. That's today's big deal. Okay, anybody can tell me what's left? There's nothing to reduce here, so that's perfect because I like 64. 64 is what? A perfect square number. So if I were to have to graph this, it works out. That one's cool. But this, something has to happen. Anybody can tell me what it reduces to? Correct. $16 goes into 64. 16 times 4 is 64, so that's how it reduces. And this looks like, and it is, the standard form for the equation of an ellipse. Okay, we got it? That's all you're doing today is just writing the equations in this form. Once it's in this form, you can graph it and do what you need to do. All right, good.